Hi everyone, today we're going to be talking about section 9.4. So if you guys look at the warm-up example, we'll just go through that together. Okay, so it says if we're given the following equation, what would we do to solve? So normally we would either divide each side by 3 or, actually we could write it out like that. Okay, and we end up with x equals 4. Is our final answer. Now it says, remember back to chapter 1, the reason why we divided by 3 is because division is the inverse operation of multiplication. So another way that we could write this, if we're talking about the inverse, that's our original equation, the inverse of multiplying by 3 is actually multiplying by 1/3. That's the inverse. Okay, so really what we end up with is the same answer. Okay, now we've seen in previous sections that another way to write 1/3, that's 3 to the negative 1 power. So that negative 1 is the inverse that we're talking about. Okay, so if we're looking for even one more way to write this, we could say, let's say we had 3x equals 12. Okay, if I multiply by the inverse, we end up canceling those out and we get x equals 4. Okay, now with multiplication you would never actually write it out this way. You would probably just do the original, but really what actually happened is that we multiplied by the inverse. Now to solve matrix equations we will use inverses as well, but this time we're going to use the calculator. Okay, now before we get to that, we're going to be using matrix multiplication to multiply the two matrices on the left just to see where this all comes from. So remember, we underline the rows and circle the columns, and we know this is a 2 by 2, this is a 2 by 1. The inside numbers match, and the outside numbers tell us that our final answer is a 2 by 1 matrix, which we know should be the case because that's what we have here. So if I were to create 2 rows and a single column, that means I have 1 entry here and 1 entry here. And remember, with matrix multiplication, we multiply the corresponding parts. So I have 6x and then minus 2y. Okay, so you multiply the next part. And then our second row, we have 2x plus 1y because of 2x and 1y. And so this is going to be equal to -2 and 6. So if we know that corresponding entries are equal to each other, that means the top is equal to -2 and the bottom is equal to 6. So there's a system right there. That tells us that any system can be written as a matrix equation. Okay, now we call this first matrix the coefficient matrix. This one here is the variable matrix. And here we have our constant matrix. Okay, so we have this example here that shows our matrix equation. This is the coefficient matrix, our variable matrix, and the constant matrix. So in order for us to solve, if we think about what we did before with our inverses, instead of dividing by a, because we can't divide by a matrix to solve. Okay, it just doesn't work algebraically. So instead of dividing, we're going to multiply both sides by the inverse of A, because this is what we're trying to move to the other side. And the order that you always have to type it in is the inverse of your coefficients times the constant. So this means the coefficient matrix inverse, and we're going to use that button in our calculator, times the constant matrix. Okay, so if we're looking at our example below and we're trying to get x by itself, okay, we're going to say x is equal to the inverse of this matrix here to the -1 power, and then times our constant matrix. Now this is what we type into our calculator. Now, let's go ahead and get that. Okay, so I'm gonna go into our matrix menu, edit that first one, and my first matrix is a 2 by 2. So I've got -3, 4, 5, -7, okay? Now, I'm gonna type in the second matrix under matrix B. Oops, I selected A again. Okay, so I've got another 2 by 2 matrix, 3, 8, -2, -2. Actually, this one was +2. Okay, I'm gonna quit out of there. And now we're ready to type them in. So we're gonna type in matrix A. Our inverse button is right here, okay? And now we're gonna type in matrix B. And so you should have something that looks like this. And if you hit enter, you end up with our final answer of -29, let's scoot that over, -48, -21, and -34. And this is our final answer. Okay. Now let's flip to the next page and see what happens when we have something else going on. So notice I've got plus this matrix here. I'm actually going to subtract it to the other side first. Okay, so that cancels this out over here. Leaves me with 4, 7, 1, 2 times matrix X is equal to, and now you subtract the corresponding entries. Careful with the negative. We've got -2 minus a negative. That turns into plus. 3 minus 4. Okay. And now we're ready to type it into our calculator. So we're going to have X is equal to the inverse of that first matrix times the second. Okay, go ahead and pause the video and you guys can plug that into your calculator. Okay, go ahead and check your solution here. So we end up with our variable matrix as this 2 by 2 right over here. Now, the last type of problem that we're going to be solving are actual systems that are written out the way that we're used to seeing them. And to do that, we're going to go back to one of those previous problems we saw and write this as a matrix equation. So you know we're going to have the coefficients as one matrix. Our variables are just x and y, so that always goes into a column like this. And our constants are on the other side. Okay. And so therefore, if we're trying to get x is our variable matrix, which is really right over here. That's what we're talking about. If we're trying to get this by itself, we follow the same process of doing the inverse of this matrix. Times the constants. Okay, and let's go ahead and type those in. So you've got a 2 by 2. Typing all those entries in. The next one is 2 rows, 1 column. So we have negative 13 and 11. And so now we can do A inverse B. Now this tells me, so my final answer is negative 4, negative 5, which means x is equal to negative 4, y is equal to negative 5. This is actually a coordinate, so you can just jump to the ordered pair as the final answer. Okay, if you had written the answer like this, that would also be acceptable. All right, so these last couple, I'm going to have you guys try number 2 on your own. Solutions will be posted as part of your scan notes. For number 3, I just want to point something out. You want to make sure each equation is written in standard form. So for example here, if I have my coefficients, I need to make sure that the equation is written out right. Notice there are 0 x's. If it helps to put that placeholder in, go ahead and do that. 0x. I'm going to move the 3 over. So we've got plus 3y plus z, no x's here. And that's equal to negative 7. Again, that's because we added the 3y to the other side. Okay, so now you can use this system to set up your matrix equation. Okay, solutions will be posted. Homework is already posted for Tuesday, and that's it. All right, have a great day.